Howdy folks, we just finished talking about adding rational expressions, and so now we're going to change over to subtracting rational expressions. Now I left the procedure for adding up here because the procedure for subtracting is the same as the procedure for adding. So I'm just going to throw up a few examples on the board. And we're gonna, I'm not gonna throw up some examples up on the board. I'm going to put some examples up on the board with my marker, and we're gonna work out subtraction of rational expressions. So let's say that we had, something like 4 over x. Let's say 2x minus 5. Minus 3x over x plus 1, okay? And we want to subtract these. Well, the first thing that we got to do is we have to factor the denominators. Well, in this particular case, the denominators are already factored. They cannot be broken down anymore, so we're going to leave them as is. So what we're going to do now is we're going to say, okay, well, what does this denominator have that this one doesn't have? Well, this one has an x plus 1. So we're going to multiply over here by x plus 1 over x plus 1. Now, what does this denominator have that this one does not have? Well, this one has a 2x minus 5. So we're going to multiply over here by 2x minus 5 over 2x minus 5. Now you may wonder, why do I keep putting them in parentheses? It's because we're about to multiply. And when you multiply a binomial, you have to distribute. Okay? Now we're not going to distribute in the denominator. We're just going to leave it as in factored form in the denominators. It's only the numerator that we're going to distribute. So now we're going to have a fraction minus a fraction. Now this fraction over here, the denominator is x plus 1 times 2x minus 5. And we're going to leave it just like that. Same thing for this fraction, x plus 1 times 2x minus 5. X plus 1 times 2x minus 5. And now that the denominator is the same, we have a common denominator, so we could subtract the numerators. All right? Over here, this numerator, we got to do x plus 1 times 4. So we got to distribute the 4. 4 times x is 4x. 4 times 1 is plus 4. And now over here, we're going to distribute the 3x. 3x times 2x is 6x squared. 3x times negative 5 is negative 15x. Now, before we jump right in here, because the next step says that we combine the numerators, what I need to warn you about is this, and a lot of people get messed up doing this sort of thing, is this negative here, we have to subtract 6x squared, and we have to subtract negative 15x. Now, there are several ways of accomplishing the distribution of a negative. And I'm going to warn you not to distribute the negative right away, because what I have noticed a lot of people will do is they'll distribute the negative and then change the sign. They'll distribute, they say, well, I'm supposed to distribute the negative, and then they'll say, oh, aren't I supposed to change the signs? You already did. You already changed the signs. Don't do it again. So figure out a way that works for you. This is the way that works for me. Okay? I start over here and I say, well, are there any like terms to 4x? No, no, yes, this negative 15x is like 4x. Okay, then I can combine them. How am I going to combine them? I'm going to use subtraction. So I'm going to go 4x minus negative 15x. And so now, what's 4x minus negative 15x? Well, minus negative means add. Okay, this is negative times a negative. That's a positive. So this 4x plus 15x is 19x. I'm going to put it in the middle here, 19x. All right, so I've got that. Then here, here's a positive 4. Are there any other constants? Nope. So what that means is that basically over here there's a 0 over here. So what's 4 minus 0 is 4. So that's plus 4. Lastly, here's a 6x squared. Are there any x squares over here? Nope. In fact, there are 0 x squares over here. That means there's a 0 over here. So 0x squared minus 6x squared, that's 0 minus 6, that's negative 6x squared. So I'm going to have negative 6x squared. This is a positive 19x. And so now I have negative 6x squared plus 19x plus 4. Carry over the common denominator, x plus 1 times 2x minus 5. And here's my answer, except I have to put in my x cannot equal. What can x not equal? Well, what will make x plus 1 equal 0? What is the 0 of the factor x plus 1? Negative 1. So x cannot equal negative 1. What about this 2x minus 5? That one's not as easy to notice. You know what I'm going to do for that one? I'm going to bring it over somewhere, 2x minus 5, and I'm going to set it equal to 0 and find out what will make it equal 0. So I take my binomial factor from the denominator, I set it equal to 0 and solve. Add 5 to both sides, cancel, and I get 2x equals 5. Divide by 2, and x is equal to 5 over 2. So x cannot equal 5 over 2. So my domain restrictions are negative 1 and 5 over 2. Okay? Let's try another one. That's a subtraction problem. Let's do another subtraction problem. This one, I'll put it up on the board, and then you can pause the video, work it out for yourself, and then I'll work it out and see if you got it right. Let's see here. Let's try, how about, let's do one that requires factoring. Let's say that I have 7 over x squared minus 3x plus 2. Okay, it's going to be one of them. Minus, and I'll make this one 2x over x squared. Let's see here. Minus 5x plus 6. Let's do that. All right. So pause the video and then go through these steps and see if you can subtract these two rational expressions. All right, so hopefully you had a chance to try this. Remember, the first thing we're going to do is we're going to factor the denominators. And if I use product sum factoring here, two numbers that multiply to positive 2 but add up to negative 3 are negative 2 and negative 1. So this is going to be x minus 2 times x minus 1. Now over here, two numbers that multiply to positive 6 but add up to negative 5 are negative 2 and negative 3. So we're going to have x minus 3 times x minus 2. So we factored the denominators, and now we got to ask, what does this denominator have that this one does not have? Well, they both have an x minus 2, but this denominator has an x minus 3 and this one does not. So this denominator needs an x minus 3. So we're going to go x minus 3 over x minus 3. And we're going to multiply there. This denominator does not have an x minus 1. So we're going to multiply by x minus 1 over x minus 1. There we go. Equals. Okay, over here, see we got our two denominators, subtract, and then subtraction. The denominators are each x minus 3, x minus 2, x minus 1. See? X minus 3, x minus 2, x minus 1. So x minus 3, x minus 2, x minus 1. X minus 3, x minus 2, x minus 1. All right? Now, the numerator, over here we've got 7 times x is 7x, and then 7 times negative 3 is minus 21, right? And then here we've got 2x times x is 2x squared, and then 2x times negative x, or negative 1, sorry, is negative 2x. Now we just have to combine. We've got 7x here, and we've got negative 2x here, so we're going to go 7x minus negative 2x. Well, that's 9x, because 7x minus negative is plus. So 7x plus 2x is 9x. 9x. Then we have negative 21 minus, well, there's no constant over here, so that's like a 0. Negative 21 minus 0 is negative 21. So it's minus 21. And then here, we don't have any x squares over here, but we do have an x squared right here, 2x squared, but it's being subtracted. So that's like 0 minus 2x squared. So that's negative 2x squared. Negative 2x squared plus the 9x. And our common denominator is x minus 3, x minus 2, x minus 1. And so now what can x not equal? Okay, what can x not equal here? Well, it can't equal 3, right? All right, because if it equaled 3, 3 minus 3 is 0. It also can't equal 2, because 2 minus 2 is 0, and it can't equal 1, because 1 minus 1 is 0. So x cannot equal 1, 2, or 3, or 3, 2, or 1. It doesn't matter what order you put them in. Okay? All right. That's it for subtraction. Hopefully that's enough of an example. There'll be plenty of problems for you to try and work out, and good luck.